Number 5, a train at a constant 60 kilometers per hour moves east for 40 minutes, then in a direction 50 degrees east of due north for 20 minutes, and then west for 50 minutes. What are the magnitude and the angle of its average velocity during this trip? So the first thing that we have to do is to draw our coordinate system so it's easier to see what's going on. So in this case, let's say this is our x direction, which points to the east. And this is our y direction, which points to the north. So the first movement, it is this is the velocity, 60 kilometers per hour to the east for 40 minutes. So let's say this is our vector A. And then 20 minutes making 50 degrees. So let's say this is our vector B. And then 50 minutes to the west. So this is our vector C. So what we have to find here is the average velocity of the trip. So the only thing that matters to us is the initial point and the final point, this point over here. So we have to find this vector that I'm going to call it vector D and find the velocity of vector D. So we have to find the displacement, this displacement over here, and divide by the time the trip took. So we have to find this displacement vector D over here. Just remember that vector D in this case is equal to the sum of vector A plus vector B plus vector C. But this is a displacement, so the velocity of vector D of the movement from this point to this point is equal to vector D over the time that the trip took. So that's what we have to do. So at the end, what we have to do is vector D over 40 minutes plus 20 minutes plus 50 minutes. So 40 plus 20 plus 50. So this is the velocity that we are trying to find. So vector D over 110 minutes, or if you want to convert it to hours, so it's vector D over 183 hours, not 100, 1.83 hours. So this is what we have to do. So we have to write vector A, B, and C unit vector notation. So we have to find this displacement over here. So let's see, for vector A, we have 6 kilometers per hour for 40 minutes. So remember that V equals delta X over delta T. So delta X is equal to V times delta T. As for vector A, so delta X A is equal to 60 kilometers per hour times delta T. However, delta T is minutes. We have to convert this to hours. So we just have to divide it by 60. So it would be 40 divided by 60. So this is equal to 40 kilometers. If you don't believe this over here, so let's do it separately. So 40 over 60 is equal to 2 over 3 hours. So maybe this convinces you better that you have to divide it by 60, or just remember that you have 40 minutes and 1 minute is equal to 1 hour divided by 60. So just replace minutes by 1 over 60. Okay, so vector A is equal to 40 in the I direction. Don't forget to include the unit, kilometers. Vector B. So for vector B, we have to find delta XB. Let's do that first. Delta XB is equal to 60 times 20 over 60 which gives us 20 kilometers. So vector B is equal to 20 times the cosine of 50 degrees in the I direction plus 20 times the sine of 50 degrees in the J direction, and this gives us, let's see, this gives us 15.3 in the I direction plus 12.9 in the J direction in kilometers. And vector C, we can do the same calculation over here. So delta xc is equal to 60 times 50 over 60, which is equal to 50 kilometers. So vector C is minus 50 kilometers in the I direction, and that's it. So vector D, you just have to sum everything, and if you do, you would find 5.3 in the I direction plus 12.9 in the J direction in kilometers. So the velocity that we want to find, you just divide it by 1.83, and then you would find 2.9. So what I'm doing here is this division over here. So 2.9 in the I direction plus 7.01 in the J direction, and now this is kilometers per hour. Okay, so this is the velocity unit vector notation. We have to find the magnitude of the velocity, which is the square root of each term squared. So 2.9 squared plus 7.01 squared, and this gives us roughly 7.59 kilometers per hour. So this is the answer of letter A. For letter B, we want to find the angle, which is the tangent to the minus 1 of the y component of the velocity over the x component of the velocity. So tangent to the minus 1 of 7.01 over 2.9, and this gives us, let's see, 67.5 degrees. So this is the answer of letter B.